Okay, welcome to our 2.1 Computing Unit Rates notes. You should have your note sheet and we're going to jump right into things. Before we get started on talking about rates, there are some things I want you to remember. The first thing you need to remember is that you always need to simplify before multiplying fractions. I know that there are some other strategies that we used previously, but this is going to be the easiest and simplest way when you get to those multiplying fractions problems. So, for example, if we have 3 over 4 times 8 over 11, I can look diagonally and see that these two are both divisible by 4. So this 4 is going to become a 1, and this 8 is going to become a 2. I can't simplify crisscross with 3 and 11, so I'll just multiply straight across. 3 times 2 is 6, and 1 times 11 is 11. Okay? Next, I can look crisscross here and I can simplify this both by 10. So this is going to become 1 and this is going to become 6. Likewise, I know that 81 and 9 are both divisible by 9. This 81 is going to become a 9 and this 9 is going to become a 1. That means when I multiply straight across, 1 times 1 is 1 and 9 times 6 is 54. Okay, which is my final answer. Alright. I'm going to solve this one for you. So this is a division problem. Remember that when we are dividing fractions, we need to keep the first fraction, change the sign, flip the second fraction, now multiply. Okay? Now that I have done that step, I'm going to look crisscross, and I'm going to see that 33 and 11 can both be simplified. They're both divisible by 11. So this is going to become 1 and this is going to become 3. Likewise, 81 and 18 are both divisible by 9. So this 81 is going to become 9 and this 18 is going to become 2. Now I can multiply straight across, knowing that 3 times 2 is 6 and 9 times 1 is 9. However, I'm not done yet. 6 and 9 are both divisible by 3. So I can divide the top and the bottom both by 3. And my answer here is going to be 2/3. What I want you to do is solve this problem and solve this problem. Then pause the video, raise your hand, and get checked by me. Then we'll move on to the rest of the notes. The next thing I want to remind you about is how fraction division can look. When you're looking at fraction division problems, they can be set up like this with the division symbol, or on top of each other with a bar. Please remember that this bar does mean division. So even when we look at fractions, this is the same thing as 1 divided by 2. It's also a half. Additionally, if you see this slash, this is also a division symbol. So add these to your notes so that you can be aware of what these look like in the future. Now, if you remember, to turn a whole number to a fraction, you place a 1 in the denominator. Okay? So for example, 20 is the same thing as 20 over 1. Negative 3 is the same thing as negative 3 over 1. And 143 is the same thing as 143 over 1. These both equal each other. So just remember that. Now let's talk about rates. A rate is a ratio that compares two numbers with different units. When we're talking about units, we're talking about things like miles per hour, or like cost per item. And we'll see some examples in a moment. These are all examples of different units. For example, a car travels 100 miles in 2 hours. The first thing we need to do is recognize the two units. Miles per hour. Notice that per, I used a division symbol. Okay? So that means that for every 100 miles, that the car travels 100 miles in 2 hours. This is how we would set a rate up. Okay? A unit rate is a rate expressed in the quantity 1. With a unit rate, the denominator is always 1. Unit rates involve phrases like for every or per, like $2 for every 3 Snicker bars, or miles per hour, okay? With a unit rate, we always ask the question, how many or how much for one, pretty much. So for example, a car travels 100 miles in 2 hours. How far does the car travel in 1 hour? This is a unit rate problem. And in order to solve, we are going to have to, number 1, set it up. Then we're going to have to cross multiply. And then we're going to have to solve for x. Alright, and this requires us using some solving equation strategies, which I'm getting ready to teach you now. So, let's look at this problem and let's get to it. First thing I'm going to do is I'm going to understand my 2 units that I'm dealing with. A car travels 100 miles. Ooh, my pen is going dead, so I'm going to switch over to my green. Here we go. A car travels 100 miles in 2 hours. So the first thing I'm going to do is set up my words, okay? Miles per hour, okay? Now, how many miles? 100 miles in 2 hours. But my question says, how far does the car travel? How far does the car travel in 1 hour? 1 hour. That means we're dealing with a unit rate. Okay? So, here's how I'm going to set this up. If the car travels 100 miles in 2 hours, I'm going to put my equal sign. How much does it travel in 1 hour? I don't know how many miles it travels in 1 hour yet, so I'm going to represent that with the variable x. X is a variable we use when we don't know what something is. So essentially we're going to try to solve for x. The first thing we're going to do is cross multiply. So that means I'm going to take my pen, I'm going to circle this together, and I'm going to crisscross and circle that together. Okay? I'm going to come to the side so that it makes it easier to solve. So pretty much what I did was multiply 2 times x equals 100 times 1. Okay? 2 times x equals 100 times 1. So now I'm going to write that as 2x equals 100 times 1 is 100. Now, what I'm going to do is I'm going to ask myself, if I need to solve for x, and in this situation I am multiplying, I essentially have to do the inverse operation to undo this situation so I can get x alone. So, if I am doing multiplication, then to undo or take the inverse, I need to divide. Okay? So, in order to get x alone, since I'm multiplying 2 times x, I have to divide both sides by 2. Okay? 2 over 2 is going to give me 1, which gets x by itself. And 100 divided by 2 is going to be 50. So the last thing I need to ask myself is, what does this 50 actually mean? It means that the car travels 50 miles per hour in 1 hour. So that's my final answer. Now, let's do some other examples. Forever 21 is having a sale on shirts, charging $15 for 4 shirts. How much would 1 shirt cost? What's the cost of 1 shirt? Okay? Now, I don't actually see the word that says cost per se in the beginning of this problem, but when I set my words up, I have to understand the situation. So, they're having a sale, and I'm going to be comparing the cost to the amount of shirts. So, the words that I'm going to write are going to be cost per shirt. Okay? Now, currently, it's $15 for 4 shirts. But I want to solve for how much one shirt costs. So I'm going to set up an equation, essentially. All right? Now, the first thing I'm going to do is, after I've set it up, is cross multiply. So I'm going to link the 15 times 1 and 4 times x together. All right, and then I'm going to write or set up my problem over here to solve for x. 15 times 1, first I'm going to go 4 times x equals 15 times 1. This is going to give me 4x equals 15. Now, same thing here. What we talked about last time. With this 4x, this is essentially multiplication. And I need to do something that's going to get x by itself. If I am doing multiplication here, then to undo or take the inverse, I have to divide. So that means I'm going to divide both sides by 4. 4 over 4 gives me 1, which gives me x alone. And when I put this in my calculator, 15 divided by 4 is going to give me 375. What does this 375 mean? What does the question ask? How much would one shirt cost? So this one shirt would cost $3.75 per shirt. And remember that this slash means per, okay, or for every shirt. All right, last problem we're going to do, let's flip to the back. Cardi eats 1/3 of a pizza in 3/4 of an hour. At this rate, how many pizzas can Cardi eat in 1 hour? So what I'm going to be comparing here is the amount of pizza per hour. Okay? Now I'm going to set this up. She ate 1/3 pizza in 3/4 hour. Okay? The question is, how many pizzas can she eat in 1 hour? So I'm going to set up my equation. How many pizzas, we don't know, in 1 hour. Now I'm going to solve this the same way. Don't be intimidated because of fractions. We're going to solve this the exact same way. Now that we set this up, we are going to cross multiply. So that means I'm going to multiply 3/4 times x equals 1/3 times 1. Okay? So here's how that would look. 3/4 times x equals 1/3 times 1. Okay? 3/4 times x, and I'm going to scoot this over so you can see, is the same thing as 3/4 x equals 1/3 times 1, of course, is 1/3. Now, with fractions, I'm multiplying, okay? But in order to get x alone with a fraction, I have to take the inverse or multiply by the inverse. By the inverse. And for those who don't know what an inverse is, it's basically when you multiply by the flipped version of a fraction. So instead of, in order to cancel out AB, I will have to multiply by B over A. Okay? So, in order to get x alone, I am actually going to have to multiply both sides by the inverse of 3/4, which is going to be 4/3. All right, we're back. Very quickly, when I multiply both sides by the inverse, this actually cancels out and leaves x by itself. And then I'm left with 1 times 4, which is 4, and 3 times 3, which is 9. So my answer is that Cardi can eat 4/9 of a pizza in 1 hour. Now that we're done, try these last two problems and come back to the screen for the answers. See ya!